All right.
Hey, I have one for you right now.
So yesterday we talked about what? It's on the board. It's one of these words.
Circles.
Circles. Now, these are all conic sections, and there's 4 of them that we're going to learn. So today we're going to learn what the third one is. But the first one was parabolas. What shape was that?
A U.
Yeah, it was like that U.
Smart face.
And then circles. Oh, that's what shape is that? Circle and circle.
Swear.
Today we're going to learn about an ellipse and what the equation looks like. Now,
Ellipse are oval.
so I found this little hair thing today. And the reason I'm using this instead of a rubber band is because I tried this with a rubber band earlier today and like snapped it on my finger trying to stretch it. So this thing I don't think is going to snap. Now, as you can see, this is a circle. And I'm sure some of you have bought them and they usually come in this shape.
Did you just say this was a hair thing?
This hair thing, this whatever it
It's
is.
a hair tie.
This hair tie is a circle. Now, which one of you? You just left it. Just leave your hair
And
tie.
you're just touching it?
Leave your hair tie. I use sanitizer. The point is, it's a perfect circle. And we talked about circles yesterday. Now, to make a circle into ellipse, if you take the circle and stretch it like this, it kind of becomes like an oval. And that's what an ellipse is. But there's more than one way to stretch it. You could stretch it like this, or if you took it and stretched it like this, it could be an up and down oval. So we're going to look and see how the equations might stretch your circle to make it either wide, like this, or if you like stretched it like this, or if you stretch it tall and make it like a tall oval. Now, if you remember yesterday, the equation of a circle said x squared plus y squared equals r squared, so like 25. Alright, so this is the equation of a circle with a radius of what?
5.
5. So if you sketched it, remember you just go out 5, and you just kind of have a circle right there like that.
No.
That's an oval.
That's on a lip.
That's an
Yeah,
oval.
it's not. It's supposed to be a circle.
No, we're going to judge you on this, Mr. Jones. If you're going to teach it, you got to have it precise.
We'll see how precise I can be.
Okay.
Alright, so let me show you what a basic ellipse might look like. It's going to still have x squared plus y squared. X squared plus y squared equals
1.
1. And then underneath x squared and y squared are going to be some numbers.
9.
I said 9 and
64.
64. Now, one thing different from a circle equation and an ellipse equation is that every ellipse equation needs this number over here on the right side. Instead of being r squared, we always want 1. So in a circle, you have x squared, y squared equals 25. We don't want equals 25. We always want it to equal 1, and then there's going to be different numbers under x and y. Now, when you go to sketch this, first off, this ellipse is centered. Look at the letters. X squared and y squared, no parentheses, means it's centered right here. That's the center of it. Now, what is bigger, the number under the x or the number under the y?
The Y.
The number under the y is 64. So what that means, if the number under y is bigger, you stretch it bigger along the y-axis and smaller along the x-axis. And here's what the numbers mean. 9 is a square number. It's what times what?
3 times 3.
So this is 3 times 3. 64 is a square number. It's what times what?
8.
8 times 8. So what that means is you're going to stretch your y 8 and 8. So you go up 8, down 8. And then you stretch your x 3 and 3. So it just goes 1, 2, 3. And this ends up being, it's all right.
It's B.
Okay, so that's what it looks like. It's stretched this way because the number under y is bigger, so you stretch it like this. Specifically, 8 and 8. Like if you had 2 of them, if you're taking your EOI test, and you had 2 of them look like they're stretched this way, that number right there means 8 up, 8 down, 3 left, and 3 right. So let's look at the next one, which is really similar. We have different numbers here. We got x squared, y squared, and 1. Under here is
49
and 25.
25. All right, this time, 49's under the x, 25's under the y. So what's the bigger number?
49.
49. Under the x. So it means stretch it left and right. So it's going to be bigger this way. Is this ellipse centered?
Yes.
How do we know?
Because it doesn't have any coefficients.
No, well, no.
It doesn't have no partners up on top.
Parentheses.
No parentheses, right? We're gonna move this around, but if there's no parentheses, It's centered. The 49 means what
7
dimension?
by 7.
7 by 7. And 25 is?
5 by 5.
So we go 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. And it ends up being like that. But it's centered. So the next one, we're going to move the center away from being on the origin. So it's not going to be centered up on the graph. And the way that we do that is replace x squared plus y squared with parentheses. So instead of x squared, you got what?
X plus 3,
So we're going to have x plus 3, and then instead of y squared,
y plus 2 over 4,
okay, what's under the x?
16,
16,
and then 4.
and then 4. Now, before I even worry about sketching this, I know what kind of shape it's going to be because
The 16 is
the
bigger.
so the 16 means it stretches this
side to
way.
side.
So let's kind of find the center real quick though. Remember,
Left.
inside the parentheses, the x is left and right, but opposite. So a plus
Left.
3 moves us
Left 3,
left 3.
down 2.
And down 2.
And the plus 2, that's your up down, but it's
Down 2.
opposite, so it goes down. So your center of this thing would be left 3 and down 2. So it's right here. Now your stretch on your x is what by what?
4 by 4.
16 means go 4 by 4. So 1, 2, 3, 4. And then the 4 is 2 times 2. So 2 up and 2 down puts you here and here. What you're going to see if you're looking on your multiple choice is that the majority of this falls in the third quadrant. So what answer do you have on that?
D.
D. The majority falls in the third quadrant. It's stretched like this. The center is down here, left 3, and down 2. All right, I think the next one up, this is where we get coefficients. Now we'll go back to yesterday real quick. Yesterday, what shape were we talking about?
Circle.
Circles. One example we had yesterday was this. 3x squared plus 3y squared equaled 108. This was on yesterday's.
Yeah.
Now, we knew this was a circle because the coefficients on x and y were the same. And if they're the same, I can divide them off. Divide all three pieces by 3. And this ended up being x squared plus y squared equals 36. That's a circle with a radius of what?
6.
6. Yeah. 36, 6 times 6. Now, instead of having these coefficients the same, though, what do we have instead?
4x squared plus 25y squared
Equals 100.
equals 100.
If we have x squared plus y squared, they're both positive, and the coefficients are not the same, that's another way to know that you're looking at an ellipse. If they were the same, we would just divide them off like they're not there. If they're different, it's an ellipse. And instead of working from this way,
You go the
I'm going to work this way. I'm going to go back to the very first thing I said.
divide by 100.
Yeah. What do I want this to be?
1.
A 1. For an ellipse, I want the right side to be a 1.
So it'll always be 1 no matter what.
Yeah, on an ellipse, and what you're going to see on the hyperbolas tomorrow is you want this to be a 1. So to get it to be a 1, 100 must be divided by
100.
100. And you have to divide them all by 100.
1 over 25.
So that's your 1. Now, they're going to choose numbers where this thing works out perfect. 4 over 100 reduces the fraction. 4 over
1/25.
1/25. So this is x squared over 25. 25 over 100 reduces to
Y
a
squared
quarter.
over 4.
quarter. So this is your y squared over 4. And as you can see, we have a simple ellipse. Which way is it going to be stretched more?
Side.
Yeah, side to side, left to right. Is this ellipse centered?
Yes.
X squared and y squared, no parentheses, so it's centered. The 25 means what by what? 5 by 5 like this. And then the 4 means what by what? 2 by 2. So it's 2 by 2. Okay, I believe we have one left.
9x squared plus y squared equals 9.
Okay, 9x squared plus y squared equals 9.
Yeah.
Okay. So let's go back to 9x squared plus y squared equals 9. Now, if you're looking at this, and you got to go, is this a circle or is this ellipse? Remember our circle equation that was like this, or I'll give you a different one we haven't seen. Say you had 2x squared plus 2y squared equals 50. That's the equation of a circle. How do I know that's the equation of a circle?
Because you can divide it, the coefficients are the same.
Yeah, and I can divide them all by what?
2.
And then it's just x squared, y squared, and 25, right?
Mm-hmm.
This one doesn't have that property because the coefficients are what?
Different.
This one's a 9. This one is a what?
1.
A 1. So it must be what shape?
Ellipse.
Ellipse. So come over here,
Divide by 9.
and we want, this arrow is going to go, I want that to be a
1.
1. So I divide all three pieces by,
No.
I want a 1 and 1 right here, so
Yeah.
divide by 9, divide by 9, divide by 9.
X squared plus y squared over 9 equals 1.
Okay, 9 over 9 makes just x squared. Since it's an ellipse, and I kind of want something underneath, I'm just going to leave the 1 there. So we fine with that? Okay, then this is going to be, this is just y squared over 9. And there it is. It's clearly an ellipse now. Which way is it going to be stretched?
Tall.
Up and down because what?
Because
The
the
y.
y is bigger.
Yeah. That's why I left the x here, so you can say, hey, 9 is definitely bigger than 1. So stretch it like this. And the stretch like this is going to be what by what?
3 by 3.
3 by 3. And is this thing centered?
Yes.
Yeah.
Yeah, it's centered. So 3 by 3. And now a 1, we haven't talked about a 1 much, but a 1 is a square. It's what times what? 1. Yeah, 1 is 1 times 1. So this is 3 times 3. This is 1 times 1. So your left right is?
1.
Yeah, so this is going to be really skinny. It's going to go up 3 and be really skinny.
What are the ones that are open
If you're talking about the ones, you see some that look like
I have some also.
like this.
Yeah.
Okay, that's what we're doing tomorrow. That's called hyperbole.
I guess A
So,
was
so
a
just to finish out what your ellipse looks like, this or this. And then tomorrow, the next thing we're going to talk about is those hyperbolas, which you might have seen on your multiple choice answers. They kind of look like mirrored parabolas. This or, yeah. And that's tomorrow. There's your 4 conic sections.
How to say